Okay, welcome everybody. We're doing lesson 6.7 and 6.8 today, further factoring. Again, we're going to look at some special cases of factoring. And in last class, we looked at difference of squares. And today, we're going to look at perfect square trinomials. Okay, so again, the perfect square trinomials keyword is the perfect square. And I'm just going to go and again, the perfect square trinomials are basically the opposite of when we foiled last unit, when we foiled two equal binomials. For example, if you remember this case here, that would be P plus Q times P plus Q. Well, when those two binomials are the same, that's a special case. So again, let's go ahead and distribute, sorry, not distribute, FOIL this case. And if you remember your little shortcut, we're going to square the first term, so it's going to be P squared, square the last term, Q squared, and then the middle term is the product of the two terms doubled, so double the product. So it's going to be plus 2P plus 2PQ. Okay, so essentially what we're doing today is we're going to look how to factor these cases and be able to go back to that. Okay, so again, let's don't worry about these notes here. Let's just jump right to a few examples. Okay, and example number one, fairly easy one here, and you'll notice that if I factor this again, what two numbers multiply to 4 and add to 4, well, we can all kind of guess that's going to be a plus 2 and a plus 2. Okay, again, so this is why this is called a special case perfect square trinomial, because the factors are identical. Okay, the factor is a plus 2, a plus 2, so that means we can write it as a plus 2 squared. Okay, so again, you have to kind of recognize here, your goal is to start recognizing which ones are perfect square trinomials. For example, if you look at this one, it's going to be x minus 2. Actually, so you can't even do this one. I should probably read the question. It says, which of the following are perfect square trinomials? Well, this has to be a perfect square, and this has to be a perfect square. Well, that's a perfect square, but that's not a perfect square. Okay, and if let's check this one out. Okay, this is a perfect square, this is a perfect square. So that would factor into, again, it has to be 2x, and then it has to be a 9, and I'm going to do a negative 9 and a negative 9, again, because I'm trying to get to negative 36. So let's go ahead and do our smiley face and check if that works. 2 times negative 9 is negative 18. Negative 9 times 2x is negative 18. Negative 18 plus negative 18 is negative 36, and that is exactly what we're trying to get to. So again, 2x minus 9, we can rewrite it as 2x minus 9 squared. Okay, all right, let's try this one out here. So it would be, we have x, and let's see if it's a minus 4. Again, this is not going to work because this here is not a perfect square. Okay, you can't have negative 4 and negative 4 because that is going to multiply to positive 16. And if it's a positive and a positive, also going to be positive 16. Okay, let's do a couple more examples here. So I have, go ahead, you try this one here. I'm going to go ahead and do this one. So again, do your brackets, and you have 4 plus 5 plus 5x, 4 plus 5x. And again, let's do our smiley face to check and see if that works. Okay, and 4 times 5 is 20. 5 times 4 is 20. 20 plus 20 is 40. So that, that works there. This one here looks like a little bit harder, but again, 1 over 9 is a perfect square because 1 over 3 squared gives you 1 over 9. So it's going to be 1 over 3a, 1 over 3a, and then it's going to be a minus 3 and a minus 3. And again, you have to have minus 3 and minus 3 because your middle number is negative. Otherwise, you would never be able to add to a negative number. Okay, let's check if that works using our smiley face. And we have 1/3 times negative 3 is going to be negative 1. Negative 3 times 1/3 is negative 1. Negative 1 plus negative 1 is negative 2. And, there it is, negative 2 there. Okay, jump down to example number 4 in the next section. This is also doing some different type of factoring where the exponent is not a squared and not a 1 here. We're used to a squared minus 5a minus 14. Okay, all right, so how are we going to do this one? Well, here's the first thing you have to do. We're going to do this. We're going to say let x equal a squared. Okay, stay with me here. If I let x equal a squared, I'm going to replace all the a squareds with x. So here I would have x squared, because I have a squared times a squared, minus 5x minus 14. Okay. If you're not quite sure how I got this a to the 4 to look like an x squared, think of it this way. Okay, think of it as if I wrote a squared minus 5a squared minus, I'm going to put a bracket here, minus 14. Well, I said that x equals a squared, therefore I'm going to replace those a squareds with an x, and that's how I got x squared minus 5x minus 14. Now I can go ahead and factor this because I know how to do this. So that's going to be x minus 7, x minus x plus 2. Okay, but what you have to do is at the end of all this, you now have to replace back or substitute back your original value for x, which was a squared. So this now becomes a squared. Okay, go ahead and try B. I'm going to jump right to C. Again, in this case, I'm going to let this whole thing equal x. I have to choose a different letter now. So x cubed, let x cubed equal, I don't know, p. Doesn't matter what you choose here. Okay. Well, now look what happens here. So x to the 6 can be written as x to the 3 squared minus 9x to the 3 plus 14. And now I can go ahead and replace all those x cubes with a p. So it's going to be p squared minus 9p plus 14. And then you can factor this into p. What is this one? Minus 7p minus 2, and then finally substitute back, instead of p, get back to the x cubed. So it's x cubed minus 7, x cubed minus 2. Okay, jump to example number 5. Example number 5 is no different, except now we have that leading coefficient. So we have to use the smiley face. So again, I'm going to kind of jump right into this. First, I'm going to go like this. I'm going to let x squared equal p. And then I'm going to rewrite this as 4p squared minus 5p minus 6. And now I'm going to go ahead and do my smiley face. Okay, I'm not going to go through the whole all the options again, but I can kind of get this one again. Your goal here is to get this, kind of figuring it out in your head. You need to get to -5 here. So the only way to get to -5 is if you multiply 4 times 3. This will be a 4p. Oops, made a mistake already. It should be 4 times 2 4 times 2 gets me to 8. The other factor here is going to be, make that a negative 2. This is going to be a plus 3, and then a p here. So let's check that out, see if it works. Okay, 4 times negative 2 is negative 8, and 3 times p is 3, so negative 8 plus 3 is negative 5. Okay, and then finally, again, you have to substitute back the x squared right there, x squared, and that is your final answer. Okay, so go ahead and try these guys. They're just a little bit harder. Here you're gonna have to make y to the 5 equal, equal x. So it's and then start there. So let y to the 5 equal x. I'll go ahead and do one more hard one here. And again, in this case, I'm going to make this x squared equal p. Let x squared equals p, and then it's going to be 8p squared plus 10p minus 3. And again, looking at this one, I need to get to positive 10. So let me see, if I do 4 times 3, yep, that's going to do it. So 4 times 3, this is going to be 2p here. So 4 times 3 is going to give me to 12. And I need to get to 10, so it's going to be minus 1 over here. And minus 1 times 3 does give me 3. Do my smiley face, 12 and negative 2 gets me to 10. Okay, and then finally substitute back the x squared here, x squared. Okay, final lesson in final example in this section here are more complex difference of squares, and you can go ahead and read through this. I'm going to jump right to the example, and for example, if I have k squared, well, that's going to be k squared minus 1, k squared plus 1. But guess what? This here, you can do more with this, right? You can do further k minus 1, k plus 1, and then this just drops down. Okay, so be careful. You can sometimes keep going, okay? Let's look at this one here. I have to factor out a negative 5 here. Sorry, not negative 5, so factor out a positive 5, and I'm left with 80 divided by 5 is going to give me 16, so it should be 16 minus x to the 4th. Now I have 4 plus x squared, 4 minus x squared, and then be careful because you're not done. This can further factor. Let me get all these guys down here. 4 plus x squared, that one's done. But this one can further factor into 2 minus x, 2 plus x, okay? All right, go ahead and try this one. The lesson here is always check if you have further factoring to do. So do your common factor first, then difference of squares, then difference of squares again. Okay, thanks for watching, and see you in class.